Hello guys, welcome back to another video in the ECET series. Guys, I have already explained digital electronics of AP ECET 2020. If you haven't watched it, you can find the video at the end screens of the video. Watch the complete video for better understanding. Now let's get into the video. In this video, we will go through microprocessor paper of AP ECET 2020. Microprocessor is completely a theory subject and you have to remember each and every point. And it's the highest weightage subject in AP in ECET 2. So note all the typical points to remember them easily. Now let's get into our first question. The purpose of microprocessor is to control dash. Mostly all go for processing as a correct answer, but it's not the correct answer. But the main purpose of microprocessor is to control memory. Now we will see how it is the functions of microprocessor. Now you can see these are the basic functions of a microprocessor, controlling all other parts of machine and sending timing signals, transferring data between memory and I/O devices, fetching data and instructions from memory, decoding instruction, performing arithmetical and logical operations, executing programs stored in memory, performing communication among the I/O devices. So you can find that memory is playing a major role in functions of microprocessor. Now let's get into our next question. If segment address equals to 1005H, offset address equals to 5555H, then the physical address is. Now let's calculate this. Now we will write segment address as s segment address 1005H. So now let's convert it into binary. 1 is represented as 0001. Zeros are represented as 0000. Another 0. We have to represent everything is into 4 bits. And a 5 is 0101. Let's leave the H. And now offset address. Offset address. What is given? 5, 5, 5, 5, H. Now let's convert it into binary. We can see that 50101. Another 50101. 0101. 0101. As you know that segment address is of 16 bits. Offset address is 16 bits. And then it is asked to calculate physical address, which is physical address is 20 bits. When we add 16 bit and 16 bit, we will get a answer of 16 bit, but it is asked physical address which is of 20 bits. So we have to change one either this or this into 20 bit, but we can change only a segment address into 20 bits. We can change this as we can add a 4 bits towards the right side. Now let's convert it into 20 bits. And then what it happens? Here we have to add 4 zeros, means 4 bits, 4 empty bits here, and move this as the same 1010 000. Here this 00001 000. Now we have to add both these 001 0 1 000, and here 1101 1 11 0, 1. Here it is 1. Here 1 0, 1 0, 1 0, 1 0. And it is here it is the same 1 triple 0 1. And now convert it into the hexadecimal. Now it becomes 0101 as 5 and 1010 it in hexadecimal 1010 which means 11 which means 10 becomes a and 0101 5 here it is also a 5 and here it is 1 and we should add h at the end. So now let's match with the options 155 a 5 h. Here there is no 5 so this is wrong, this is wrong, this is correct. Here this is wrong, so this is the correct answer. You have to must learn all the conversions. I have placed a link in the description. Damn it for learning calculations in depth. And now let's move to our next question. Which of the following instructions is not valid? If you see that move ax comma bx, these are these are registered. We can use these registers for moving as here move x move and here given an operand. Okay, it also works. It also works. Here push ax. It also works. But here it is given a data segment. DS refers to data segment. Hmm, so this don't work. So the correct option is third option. It is not valid. It is not a valid instruction. Now let's move to our next question. The the addressing mode that is used in unconditional branch instructions is the addressing mode that is used in unconditional branch instruction is unconditional branch instruction means which do not need any condition to transfer the instruction. And some of the unconditional branching instructions are return, which is as noted as read, jump, call, loop, and these unconditional branch instructions uses intra-segment indirect addressing mode because the branch in address is found as the content of the register or a memory location. Now let's move to our next question. Mm, During comparison operator, the result of comparing or subtracting is stored in dash. The answer is nowhere because we don't store the comparing result. So now let's move to our next question. The instruction jump belongs to. As we seen earlier, jump bill is an unconditional branch instruction. So now let's go through the option. Sequential control flow instructions. No, it is not a sequential control flow. Data transfer instruction. No. Branch instruction. Yes, it's a branch instruction. Here the another option. Control transfer and branch instructions. This is also correct. But for a correct accurate answer, this option will be the accurate answer instead of this. Now let's move to our next question. The first processor with an inbuilt floating point unit is the 32-bit CPU of 80486 from Intel is the first processor with an inbuilt floating point unit. The same question is also asked in ts-ecet 2020 paper also. Now let's move to our next question. Which group of instructions do not affect the flags? which do not arithmetic operations affect the flags. So this is not a correct option. Logical operations affect the flags. So this is not a correct option. Branch operations also affect the flags. So this is not a correct option. And finally, data transfer operations. This does not affect any flag. The data transfer is automatically happen without any interruption of to the flags. Now let's move to our next question. The addressing mode which makes use of indirection pointers is indirect addressing indirect indirect addressing mode. The answer is indirect addressing mode contains instruction contains the address of the location where the target address is stored. Now I will show with this with an image so you can understand better. Here you can see this is the instruction containing opcode and address of of the of a pointer, and this pointer referring to the operand. So there is a two-way step. So this is called as indirect addressing mode. Now let's move to our next question. What is the highest speed memory between the main memory and CPU called? We have the options register memory, cache memory, storage memory, virtual memory. Cache memory lies in between the main memory and CPU. We have level 1 and level 2 caches also, and where level 1 cache is the very close memory to the CPU. So the correct option is cache memory. If it is given as level 1 or level 2, there the answer will be level 1. So now let's move to our next question. In the following indexed addressing mode instructions, move 5 of AR1 location of effective addresses. Here 5 5 is a offset address, and next here it is given R1. R1 is the base address. So now let's it is asked for effective address. Let's it makes us EA, and now it becomes 5 plus R1. But if you see that base address should be always in square brackets. So this. Now let's see this. This is not the correct option. This is not the correct option. This is not the correct. Here it is the correct option. Now let's get into our next question. It's the final question. The instructions like move or add are called as. For any instruction, we will have opcode and operand. For example, let's take move al, comma 34h. If you see that this is called as opcode, and these are the operands. And this opcode is a single instruction executed by CPU. It's a single instruction, and this operand get manipulated by opcode. By using opcode, we will manipulate these operands where the data is changed. So the answer move, add, jump, etc. comes under opcode. So this is the correct answer. And these all comes under operands over here. And that's it for the day, guys. If you did not watch the day video, that will appear in the end cards. So go through it also. If you found this helpful, like and subscribe, and also share with your friends.
Thanks, Namaste.